Hello, people. You are back in physics. I'm sure you're excited. Okay, so we're taking notes today. We're talking about distance time graphs. We're going in a little more depth than we were talking about them in groups yesterday, okay? There's your title, Interpreting Distance Time Graphs. So why don't you write it down? Write it down, 1.2, okay? While you are doing that, I have a meme for you. If you turn a picture of hanging bats upside down, they look like they're doing the Thriller video. Yeah? You know, Michael Jackson. Okay, so let's start this up. First things first, I have a video for you guys. Oh, look at it. That is a good looking dude. I found this video on YouTube. I don't even know who it is. Okay, so let me just enlarge it a little bit. Okay, I'm gonna let it play through once, and then I will go back to the parts that we need to use so you know what's gonna happen in the video when we start to measure things, okay? And here we go.
Hi guys, I'm outside in my front yard because we're going to record a quick lesson. First, I've set up something. You'll be doing this in the future, don't worry. So this is kind of a setup for you. What I've done is on my sidewalk here, I've set up a bunch of golf clubs to measure off something. If you can see, every golf club is the same distance away from each other. And I just want to show you that distance and how far it is. So they're all measured. They're all by this this line on the floor. And if you can see, every block on the floor is 5 feet apart. Okay? So what I'm going to do is I am going to run, jog, hop, do different things between the different golf clubs. So each golf club is 5 feet apart, and we're going to use this to graph some stuff and just talk about my velocity and things like that. Okay, I'm going to set it up. See you in a second. Now, remember, it's 5 feet, so we got 5, 10, 15, 20, 25 feet of poles here.
5, 10, 15, 20, 25. Oh, look at that. Strutting. Look at that walk. Oh, man. Okay, and then, oh, look, jogging. He looks like he's in shape. Oh, look at that backwards run. Watch out behind you. Don't hit anything. Okay, it looks like, okay, and then he did a sprint. Okay, cool. Okay, so let's just talk about what he did real quick. He walked the first 2 of these, so that's 10 feet, and then he jogged 10 feet, and then he backwards jogged 15 feet, and then he sprinted the full amount, right? Okay, so on your own sheet of paper, we're going to do a position time table, and we're going to make a little graph on it as well. Don't you all feel lucky? Okay, so let me, oh, you know what? I need to save this. I need to put it as a PDF. So while you are making that table, I will be doing this. Okay, there it is. Okay, bring that, do comments, get rid of that. Okay, now let's write some stuff down. Okay, we got a position timetable now. Okay, I'm gonna write some stuff on the side here to keep us kind of organized. At first he did a walk, that dude a walk, then he did a jog, and then after the jog he did that backwards run, right? That was dangerous. And then he sprinted forward, and I don't know, he looked like he might have been going faster than Usain Bolt. I think we should check that dude for a world record, but I'm not sure. Okay, so the position, remember, we were measuring in feet. And when the walking was going on, he walked 10 feet. And then in the jog, he walked 10 more feet forward, remember? And so that put him at 20 feet forward from the original position. Then he jogged, he did a backwards jog, remember? That dangerous thing he did. And he went back 15 feet, which brought him to the 5 feet region from the original position. And then he sprinted forward past where we only measured 25 feet, so we'll stop it there. Okay, now we did not measure times though. We need to know times. So let's go back to that video and I'll put a timer right here on the screen, and you can see if I'm doing it well or not. But I don't know. I'm pretty good at timing. We'll find out. It just takes me forever to find it on my phone. Okay, here we go. Okay, I'm going to use this one, the one that does lap. And that way I can just press lap and then I'll know what happened on each one so I don't have to stop the video every time. Okay, so let's try to find where that begins.
So each golf club is 5 feet
I'm going to
apart.
bring down the volume there. Okay, let's see here. Fast. Okay, here we go. Here we go. So let's try to get that. Okay, it looks like the timer's in there now. And you can see I'll press all the stuff when it happens. Okay, when he starts walking, there we go. Getting some time in. There's 5 feet. And there's 10 feet. And then he jogs. And then he backward does it. Going the backwards all the way to 5 feet. And then he sprints. And boom, there we go. Okay, I got them all down. Let's get rid of that. Here, stop talking, dude. Stop talking. Okay. Now, let's write all this stuff in. I got it all right here. Okay, so the first 10 feet, that took that dude 7.7 seconds to walk 10 feet. And then the next part where he jogged, it took an extra 2.8. Okay, now I'm a bad person. I need to turn on my calculator. I forgot. I can't like add them in my head that quickly there. So 2.8. So 10.5. That was not a difficult one. Okay. 10.5 seconds is how long it took him to do that jog there, or the extra time. So remember, it only took 2.8 seconds to actually do the jog, right? We had to add it to it. Okay, and then the backwards jog took 6.8 seconds, okay? So 10.5 plus 6.8, that brings us to 17.3 seconds in total. And then that incredibly fast sprint he had took a time of 1.6 seconds. That's fast. And that brings us to a total time of plus 1.6, 18.9. Okay, so we got everything we need to know here. Okay, so it looks like the walk, he walked for 7.7 seconds. He jogged for 2.8 seconds. He back sprinted for 6.8 seconds, and then he sprinted for 1.6 seconds, bringing the total amount of time to do everything to 18.9 seconds. Okay, now I want to look at those things on a graph here, okay? So let's go like this. Okay, let's label some stuff on the graph. So if you're not good at labeling, maybe this will help you out. Okay, so we need like 19 seconds on here. So what you could do is count how many lines there are and make sure that you're making a solid number here. Let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 19. Okay, so there's 19 right there. So I'm not going to be able to like double the amount. So I'm just going to do every line is going to count as 1 second. So we got 1, 2, and sorry guys, it does that thing on the first one that I draw. It's annoying, but what are you going to do? 6, 7, 8, 9, 10, 11, 12. It's getting small. 13, 14. Okay, that one right there is going to be 15. That'll give us a little bit of space there. 16, 17, 18, and 19. Okay, and that brings us to the end. This is going to be our time. And normally we put time on the x-axis, or as the independent variable, right? Okay, and we measured it in seconds, so we should probably do that. Okay, on the side here. Now, I don't know how good you guys are at writing sideways. I can't put the paper sideways, but here we go. This is gonna be my position. So I'll just do POS, position, not POS like the. Ugh. Okay, so it goes to 25 feet. I will do like let's do every 5 feet, like I would measure it off, and we'll do it like every. How about like 3 of these? So there's my 5 right here, and 1, 2, 3. Here's my 10. 1, 2, 3. Here's my 15. Okay, 1, 2, 3. Here's my 20. 1, 2, 3, and there is my 25, the ending. Okay, and we measured our position in feet. Okay, so let's graph all this stuff out and see how it looks on a distance time graph. So I walked, or not I, the person on the video, walked 10 feet in 7.7 seconds. So 7 seconds, 7.7 is about right there. 10 feet is right there. Okay, and so that is me walking, right? That is the walk. Okay, now what do you think the next one, the jog, how is it going to look on the graph? Do you think it'll be less steep or more steep or about the same? Like, what do you think is going to happen here? Okay, and I will do that as you think about it. It's a position of 20 in 10.5. So we go to 10.5, which is right there, and we go all the way up to 20, which is right there. And that's my jog. Yeah? Okay, so it looks like when you move faster, the line will be steeper, correct? Okay, next thing, the backwards jog, and I went all the way to 5, so it's going to be to here, and we did that at 17.3, so it'll be right here, 17.3, and we went to 5, which is right here. Okay, and that's the backwards jog. Okay, and I'm trying to connect these with as straight as possible as I can. Okay. So that's the backwards jog, and then I sprinted forward, and that took me to 19 seconds pretty much, and that's to 25 feet, and look at that. Now remember, my sprint would have been my fastest thing, so that would have the steepest slope, right? Okay, cool. And notice when I was going backwards, it is a negative slope. Yeah, every time I went forwards, it was a positive slope. So look at that graph. I hope it kind of makes sense to what happened in the video. Now let's answer a couple questions based off of that. Okay, first one. What velocity was I going during each interval? Okay, well that should be easy to calculate. Remember velocity? Here, I'll go up here and I'll do it right here. Velocity is simple. Velocity is just the formula distance over time. And that thing that you can't see is a v. It's just v equals distance over time. Yeah? That's simple. So to calculate each velocity for like the walk and everything, all you do is how far we traveled. So let's do it for the walk. How far we traveled, 10 feet, divided by how much time it took, 7.7 seconds. And so my velocity for that was 10 divided by 7.7. And so I was going 1.3 feet per second. Okay? So that is the first one there. Here, let's go down and write it in. So my walk is 1.3 feet per second. Okay, I'm going to do each one of them. Okay, the next one, we got the jog. So it's distance over time. Okay, equals. That's supposed to be an x. Okay, distance is, we went 10 feet when we were jogging, and we did that in 2.8 seconds. So 10 divided by 2.8, that comes out to 3.6 feet per second. Okay, and then I'll do the next one. So it is 17, so remember it's distance over time, and it will be, we went a total of 15 feet, right? Remember we went backwards, 15 feet in a 6.8 seconds. And let's see how fast we're going. And we actually went backwards 15, so we usually put a negative there. So it's 15 divided by 6.8, and that comes out to 2.2 feet per second, and negative because it was backwards. And then the last one here, distance over time for that sprint, which we can check it against Usain Bolt with that. Okay, it went 20 feet divided by the time it took, 1.6, And so 20 divided by 1.6 is 12.5. So 12.5 feet per second. Okay, so there's all my numbers. Here, let's go write them down. 3.6, okay, so the jog was at 3.6 feet per second. Sorry, sometimes this pen doesn't work too well. Then it's the backwards jog, and that was 2.2 feet per second. And then it's the sprint, and that was 12.5 feet per second. Okay, so rank my velocities from slowest to fastest. Okay, and oh, remember, backwards is like that. Okay, so what's the slowest? Well, some of you might be thinking the walk, but if we're talking about slowest, I mean, negative is a smaller number than a positive. So if we're talking about slowest, it would have been from the backwards to the walk would be the next slowest. And then jog was the next largest number, right? And then sprint was the largest number. So that is the rank my velocities. Backwards is the smallest velocity because it is negative. Okay? Now, here's the difference here. Now I need to rank my speeds from slowest to fastest. Okay, there's a difference here. There's a difference between velocity and speed. Okay? Velocity, and here I'm going to write this down. You should definitely write this down. Velocity is the magnitude of how fast you're going. So like 1.3 feet per second, 3.6 feet per second, 2.2 feet per second. That's what magnitude means. And then velocity also includes direction. That would be your positive or negative. Now speed doesn't include direction. All it is magnitude. So if we're talking about speed here, if you're just talking about magnitude and you're ignoring positives and negatives, you would say, oh, well, walking is the slowest speed. Then it looks like the backwards sprint was the next slowest thing you can do. Then you got the jog, which is the next slowest, or getting to the fastest. And then the last one is the sprint, which is the fastest one. Now, just to engrave that into your head, I'm going to use an example that maybe you guys have noticed. We have speed limit signs here in America. So if you go over onto Interstate 10, I-10, it says the speed limit is 60, right? It doesn't tell you which direction you're supposed to do it in. It just says that the speed is 60. So if I want to do it in reverse and a cop pulls me over, I'm going to be like, hey man, you said the speed was 60. You did not tell me which direction I needed to be going. Okay? Now, Mexico has it right. I don't know if you guys have ever been over to Mexico. They don't have speed limit signs. And now you're going to hear me speak Spanish. They have máxima velocidad signs. Yeah? And so they're telling me it's a maximum velocity. It has a direction. You need to be going straight. So if I get pulled over going in reverse, that's my own fault. I just don't know my definitions of velocity and speed at that point.